Hello there, I have here an example problem of sampling distributions. So let's get started. A slot machine wins on 23.5% of its spins. Outcomes are known to be independent. If you play the slot machine 220 times, what is the probability that you win on at least 25.2% of your spins? So to answer this question, we have to use the following formula. We need to use the population's proportion, denoted as p hat, subtract the proportion of the population, denoted just as p, divided by the standard deviation of the sample proportion. You can get this by doing the square root of the population proportion, multiply 1, subtract the population proportion, divided by the sample size, which is going to be n. So what do we know here? We know p hat, which is the sample's proportion, is given in the question as being at least 25.2%. So we're going to put this down, 0.252%. We know our population proportion P is going to be 0.235, and we know our sample size. Our sample size is stated as being 229. I should have said this formula here is going to give you a z-score, and the z-score is what we're going to be using on the standard normal probability table to get our answer. So let's just go ahead and plug in the values now. We have 0.252 subtract the population proportion of 0.235 divided by the square root of population proportion 0.235 multiply 1 subtract that same value divided by the sample size, which is 229. If you did this calculation out, you would get an answer of 0.61. This is going to be our z-score, the z-value. The next step is just to go on to the table and get a proportion out. Going to the table, we need to look for an associated proportion that's to the z-score of 0.61. Here is 0.6, and here is the 1 section. Coming over here, we have this answer right here, 7291. Going back, 0.7291. But we're not finished yet, because if you look at the question, it's asking what the probability is of you winning at least that amount. At least means this amount or greater. What is that proportion? What we found was that proportion or less, meaning we just have to do 1 subtract this proportion to get the final answer. If you were to do that calculation out, you would get 0.2709, which sure enough is the answer we have right here. So that would be how you solve the first question regarding sampling distributions. Let's now move on to the second question. Suppose it is known that 31% of all Reese's Pieces candies are yellow. You buy a large bag containing 190 candies. What is the probability that the proportion of yellow candies in your bag is between 0.266 and 0.333? Again, we will be using the same formula. Our goal is going to be to standardize these two values here. For the first value, 0.266, that's going to represent our proportion of the sample, the first one. So it's going to be this, subtract the proportion of the population, which is given as 31%, or 0.31. We divide this by the square root of our proportion for the population, 0.31 multiply 1 subtract 0.31, divided by the sample size, which is given as 190. This will give us a z-value that we can use on the standard normal probability table to get a proportion. And if we were to do this calculation, we would get negative 1.31. Let's go ahead and go back to our table and find that value. We're looking for negative 1.31, so that's going to be up here somewhere. Here is negative 1.3, and here is 1. So we have 0.0951. This is going to be the associated proportion to the left side, the 0.266 right here. And now we have to find the right side. So we just have to do all of this calculation all over again, but for the 0.333. Here is the new calculation we would have to do. All I did was swap out the sample proportion with 0.333. Now we need to calculate this. This gives us a z-score of 0.69. Going back to our standard normal probability table, we're looking for now 0.69. So here we have 0.6 going all the way to the right where the 9 is. We have this proportion right here associated with our z-value, 0.7549. So going back here, we have 0.7549. Let me clear up some space here as well. Let's give ourselves some room to work. Now the next step, because here we calculated the z-value for the right side. Now, whenever we want to know the probability of a proportion being between two values, we subtract the right value or the higher value by the lower value. The higher value is the one to the right. We got a proportion of this right here, 0.7549, and we have to subtract this by the lower value, which is 0.0951. This will give us the area in between these values. Because if you recall from normal distributions, each z-score gives you, or each proportion is representing a z-score, but the proportion itself is everything towards the left of that z-score on the standard normal probability table. Therefore, subtracting the higher one from the lower one will give you the area inside. Doing this calculation out will give you 0.6598, which as well is the answer. This is how you would answer question B. This is the conclusion to this video. If you have any questions, feel free to ask in the comments section below. I will answer your questions, and I hope you're having a nice day.